18.2 to 18.3 equations of circles. So the objective is students will determine how to write an equation of a circle when given the radius and center point, or vice versa. So let's first figure out how we came up with this equation. Let xy represent any point on a circle. So we have a picture over here with xy as a point on the circle, with the center, the origin, that's at 0, 0, and a radius of r. So the radius would be represented right here by this hypotenuse. By the Pythagorean theorem, we can say that x squared, if we go this direction, it's the x direction, plus y squared equals r squared, right here. So this is the equation of a circle with a radius r with the center at the origin. But when it's not at the origin, when the center of the circle is not at 0, 0, we can write the standard equation of a circle as x minus h squared plus y minus k squared equals r squared. And in this equation, hk is the center of the circle. So I would just substitute h in right here and k in right here. Now notice the negative in the equation right here means that I take the opposite sign of hk. So if it's positive h, then it's going to be negative in the equation right here. And the square root of r squared is the radius of the circle. So let's write the equation of a circle given its center and radius. So the first one just has a center at 0, 0, so at the origin, and radius of 5. So this one is simply x squared plus y squared equals r squared, which is 25, since 5 squared is 25. Number 2, the center is at 3, 5 this time. So if I look at my equation here, this is h and this is k. So in my equation, 3 is negative and 5 is negative when I put it in right here. So I'm going to have x minus 3 squared, and that's just following this equation right here, plus y minus 5 squared, and that equals the radius squared, which would be 16. Number 3, the center is at negative 4, positive 5. So if I were to write this, I would have this time x plus 4, because the sign is going to be opposite. So if it's negative here, when I put it in the equation, it's positive. That's what this negative up here means, is take the opposite sign. So x plus 4 squared plus y minus, white out, y minus 5 squared, minus right there, minus 5, I'll put a little space, squared, equals 49. Because that's 7 squared on this side. Add radius squared up here, so 7 squared. Number 4, 2 is negative and 3 is negative. So in my equation, they're going to both be positive. I'm going to have x plus 2 squared plus y plus 3 squared equals 11 squared, which is 121. So now we're going to look at some equations, some graphs, and we're going to write the equation of the circle by looking at the graph. So let's first look at this one. The origin, or the center of the circle, is at the origin, at 0, 0. So all I need to know then is the radius. And it's 1, 2, 3. So it's a radius of 3 right there. So my equation, since it's at the origin, would just be x squared plus y squared equals 9. I could put x minus 0 squared plus y minus 0 squared, but that's really unnecessary. It would just get me right back to this step. Now number 2, my origin is at negative 2, positive 4. So negative 2, positive 4, not the origin, excuse me, the center of my circle is at negative 2, positive 4. So my equation would be x plus 2 squared plus y minus 4 squared equals, now I got to count the radius. 1, 2, 3, 4. So it has a radius of 4. that would be 16 when I square it. Okay, example 1 down here says determine both the radius and center of each equation. And then graph the circle. So the center of this one, the center would be positive 3, negative 2. I got to take the opposite signs here. The radius is going to be the square root of that number. So the square root of 4 is 2. So now I can graph this. So 3, negative 2 is the center, so I go over 3, down 2, that's the center. It has a radius of 2. So if I kind of just sketch all the way around, I'm going to use my compass if it works. I didn't test it out beforehand. But I'm going to put my compass point right there with a radius of 2. It's right there. Let's see if I can draw a pretty circle. Maybe not. Oh, broke it. I don't know if it's worth the time on this. We'll try it one more time. If it doesn't work, just let you take my word for it. Oh, these aren't the best. Oh, alright. We'll just try to draw one here. Let's see how good I am at freehanding a circle. Not too great, but that would be a rough sketch. Okay, number 2. The center. I'm having a little trouble focusing. Let's see if I can fix that here. Okay, the center. So since 1 is positive, x plus 1, then my x value is going to be negative 1. And since y is negative right here, or the k is, then my y value is going to be positive. That's my center. My radius is the square root of 9, so it would be 3. So if I go negative 1 up 2, that's my center, with a radius of 3. Now I got to try to draw a circle here. This is why I like to use a compass, because I'm not very good at this part. But that's kind of what our circle's supposed to look like. Okay, find the diameter of the circle with the given equation. So if this is the equation right here, x squared plus y squared equals 49, I know my radius is 7, so my diameter has to be 14, because it's double. On number 2, 25. So if I take the square root of that, my radius is 5, so my diameter would be 10. Number 3, I have 16 here. Sorry, my lighting's not very great today. So 16 is my radius squared, then the square root would be 4, and the diameter would be 8. Okay, number 1. Let's try a challenge problem here. Circle P is represented by the equation x minus 4 squared plus y plus 1 squared equals 36. Determine the equation of a circle that has the same center as circle P but whose circumference is twice that of circle P. So I know I'm going to have x minus 4 squared plus y plus 1 squared. But it's not going to equal 36 this time. I got to figure out what it's going to equal. And the reason why it's the same is because it has the same center. So the radius of this one is 6. So if I were to find the circumference of that, I would have 2 pi times 6, or 12 pi, if I leave it in terms of pi. So if I need to find a circumference that's double that, it's going to have to be 24 pi. So what would that make my radius be then? So what I'd have to do is I'd say 2 pi r equals 24 pi, because that's the equation for circumference. So, and it equals, that's the answer. So if I divide both sides by 2 pi, I get the radius equals 12. Okay, so if my radius is 12, I still have to find the equation of the circle. So this would be 12 squared, or if I put it in my calculator, I know it's 144. I don't know I have to use my calculator, but 144. Okay, number 2 says determine the equation of a circle that has the same center as P, but whose circumference is 3 times that circle P. So I know this first part, again, is the same. X minus 4 squared plus y plus 1 squared equals, now this time it's not going to be 144 or 36. I need it to be 3 times the circumference when I have a radius of 6. So we found out with 36 my radius was 6. Okay, and that gave me a circumference of 12 pi. So I need to triple that this time. So I need it to equal 36 pi. I need 2 pi r, 2 pi times the radius to equal 36 pi. So if I divide both sides by 2 pi, I get r equals 18. So the radius would be 18. So remember, when I put it back in the equation, I need to square 18. I don't know this one off the top of my head. 18 squared is 324. Now I need to figure out how we can use algebra to determine whether a given point lies on a circle. So if I have a center at 0, 0, and 5, 0 is a point on the circle, if we look at our picture here, that means my radius is 5. So let's just first write the equation of this circle. So it's going to be x squared plus y squared equals 25. The question says, is 4, 3 a point on the circle? In order for that to be true, it has to satisfy this equation. So I can take 4 squared, and I get 16, plus 3 squared, and I get 9, equals 25. And that is true. 25 does equal 25. So yes, it is on the circle. And it certainly looks like it. If we go over 4 and up 3, that's right here. It certainly looks like it. Now, but we can't always go by looks. We have to test it. Okay, let's try this next one. 3, 0 is the center. So that's right here. And 3, 2 is a point on the line. So I know my radius is 2. So let's first write the equation of the circle. So it'd be x minus 3 squared plus, now if it's y minus 0, I can just write y squared. I don't need to put y minus 0 because that's subtracting 0 from y gives me y. And that's going to equal 2 squared, which is 4. Now I have to test and see if this point is on the circle. Now don't get scared just because it says a square root number. Let's try it. So let's put 4.5 in for x. So we have 4.5 minus 3 squared plus the square root of 3 over 2 squared. And we'll see if it equals 4. We're testing it. We're seeing what it equals. So 4.5 minus 3 is 1.5. And when I square that, I get 2.25 plus. Now, to square the square root of 3, because when I have a fraction squared, I have to square the top and the bottom. So the square root of 3 times the square root of 3. I'll write it up here, the top part. That gives me the square root of 9, which is just equal to 3. So on the top I have 3. And then on the bottom I have 2 squared, which is 4. Now since one's a decimal and one's a fraction, it's much easier to add these if they're both decimals. So 3/4 is the same as 0.75. And I have 2.25 plus 0.75 equals 3. So this is not true. This one would be no. Okay, let's try this point. So that means I got to come back to the equation and substitute in those points. So I'm going to say 4 in for x. So 4 minus 3 squared plus, and then the square root of 3 squared. 4 minus 3 is 1, and 1 squared is 1, plus, and then square root of 3 squared is 3. We found that out up here. Oh, you can't see what I'm writing. So 1 plus 3 equals 4. So since this one does equal 4 on both, then yes, this is a point on the line. That's it.